All right, so today we're going to be looking at an alternative to what you learned yesterday, because there's times where you will not want to use substitution. And that all comes with looking at the question and going, okay, that would be ugly to do substitution. That's going to give me tons of fractions. And, you know, somebody already talked to me about, yeah, this one question had fractions in it for the substitution. And as soon as I saw that, I would go, okay, that would be better to do elimination. Okay? So this way I prefer, because as you get higher up, the equations become more complicated. And the more complicated they are, the tougher substitution gets. Tougher meaning way more fractions. Sometimes you can have up to 7, 8 different numbers going at one time. The equation is huge. When you take a big equation and you put it into another big equation, you can obviously see how ugly it gets. And when you have more than two variables. When you get into 3 variables, substitution is a pain, okay? Yet, you can give me 5 variables, and elimination is a lot of work, but it's about a quarter of what substitution would be, okay? But these ones, we're going to keep pretty tame for you in grade 10, but next year there's a whole unit again on these, and grade 12, it's just embedded into everything, okay? So obviously something that you do not want to be at a disadvantage of next year when it's a whole elimination thing again, and you're like, crap, I didn't learn that last year. Okay, I didn't learn how to walk last year, and now we're running. It's going to be a challenge, so we don't want you there. Now, the elimination method, again, mathematicians are not that creative. Substitution, you remember, you substitute. Elimination, we're going to get rid of something, okay? And by getting rid of something, it makes our life easier. But we have to know how to do that, okay? Now, when you start to see that there's a lot of coefficients in front of the numbers, see, these are all coefficients, okay? And if you look back to substitution, they were always nice, right? There was always one x or one y that had no coefficient in front of it. It's just y. You get it all moved. Or on the quiz, right? The first one was already x equals. I mean, those are nice. But this, to get this, like, look at the first equation. To get that x equals, you're going to have to first subtract 4y, right? Then you're going to get 3x equals 29 minus 4y. Then you got to divide by 3 to everybody. And you'll have x equals 29 over 3 minus 4y over 3. Now, how would you like to take this and put it into here and now keep going? It is not easy, okay? So we're going to, for this year, we're going to kind of have a rule. If it's not, there's not an x or y equals, but it's a 5x, 2y, let's go to elimination, okay? Elimination doesn't get more difficult the bigger they get. Substitution gets more difficult the bigger they get, and the more the coefficients are. And hey, we haven't even said, well, what if that was 3/4 x plus 4/3 y? You know, I could take that to a whole other level where most people, if I just did that, I bet you I could get 2, maybe 1 or 2 students that could get it right without making a mistake, right? So we do want to go to a way that is nicer. So I'm not going to go into more detail of how this will not work well for substitution, but we're going to learn how to do elimination. Now, the first thing I want to do is, I'm out of room here, right? So I'm going to just write this again. 3x plus 4y equals 29, and 2x minus 5y equals -19. Now, do you see? I strategically wrote it so the x's are above each other, the y's are above each other, and the numbers are above each other. That is crucial for elimination. You got to be organized. You want to make it look good. Now, I want to add or subtract those two lines together. And I'm going to get a new equation. Okay? Now, if I added, subtracted, let's say if I added those two lines together, I would get 5x minus 1y and 10 if I added those together. Did I eliminate anything? Did I get rid of x or did I get rid of y? No. Okay? How about if I subtracted the top from the water? What if I went like this? Well, that's going to give me 1x, 9y, still didn't work. Okay? So elimination, right now, I can't even add the two together. Like if this was a negative 3x and the bottom one had a 3x, added again, I get rid of one. I eliminate an x. But it's not like that for this one. But the greatest thing about equations, like if I had 1 plus 3 equals 4, does everybody agree with that statement? Now if I take everybody and multiply them by 2, I will get 2 plus 6 equals 8. Okay? It does not change the equation. Now if I just do 2 of them, I've changed the equation. If I just did one of them, I just picked a random one multiplied by 2. The first one, multiply that by 2. That wouldn't work anymore. If you hit every term and multiply it the same, you do not change the equation. I could prove this over and over again. Now, why does that serve me? Well, if I can do, say, multiply the entire top or the entire bottom by a number, I could keep the equations the same and I could eliminate. Now, this is actually a tougher question. Like this is a little bit more advanced than I'd want to start off with, but it's the one we've been given, so let's deal with it. Now, like I've always talked about chess, right? You got to be thinking ahead. I want to get rid of either the x's or the y's. I can add the two lines together, I can subtract, I can do what I want. But right now, I've added, subtracted, not going to work. But what if I wanted to get rid of the x's? Okay, could I just multiply the top line by anything to make the x's this same top and the bottom? What?
You have to multiply both by the same number, or you
Nope.
choose
Two different numbers.
So I was just thinking like multiply the top division by 2 and multiply 3.
Okay, so if I did that, and I multiplied this by 2, now I'm going to change it a little bit. I'm going to multiply this by negative 3. Because I like to add. I like to add to eliminate. So again, I'm thinking ahead what I like to do, and I'm going to make that happen. Now what happens if I take the entire top and multiply by 2? This would give me 6x plus 8y equals 58. Now, if I take and multiply this, negative 3 in, I will get negative 6x what's next? Plus 15y equals 57. Now, if I add those two together, do I eliminate something? If I subtract those two, will I eliminate something? No. If you like to subtract, you probably would have multiplied your bottom by 3, and then you could subtract the 2. But students mess up subtraction a lot. I always like to do what gives me the greatest chance of success. Okay? So I'm going to try to teach you add. It does work better. Okay? Now, if I added the two lines together, Do you see how I get 0x? 8 plus 15, 23y equals 150. Now, what am I going to do with 0x? If you had 0 dogs, how many dogs do you have? None. Okay? You don't have any dogs, right? If you're bragging about your 0 dogs, you're just weird. Okay? So if you have 0 x's, you really don't have any x's. Some students will say you have 1 x there. I'm like, what? Why do you have 1 x? Well, look, it's right there. I can touch it. There's an x. Okay? Well, but it says 0 x's. Okay? The 0 means you don't have any x's. Okay? If you say you have 0 dogs, you have a dog now. You don't, because you have 0 dogs. Okay? Just something you're going to have to come to terms with. You know? Take time. You can come in late lunch. We can talk about it. But you don't have a dog. Okay? Even though you say you do, you have 0 dogs. So now I have 23y equals 115. What can I do? Divide by 23. Divide by 23. Y equals 5. Okay? Now, how do I find my x? Plug in y to either one of your equations. Choose the easier one. Sometimes one is just like, and the other was this little thing. And I've seen students put in this huge one. I'm like, you got to be a sucker for punishment. Like, you're putting yourself in a more difficult position. You've chose that. Okay? Now these ones, it's a pretty well toss-up, which is, I'm going to go with the first one because there's no minus signs. Like, but who cares? It will work. So then I have, now I'm going to take my y and I'm going to place y equals 5 into either equation. Doesn't matter. Because what is the answer? The answer is what they both share, what they both have in common. Okay, Prashant, you should really write this stuff, right? Okay. So 3x plus 4 times 5 equals 29. 3x plus 20 equals, whoa, I don't know why I did that. Okay, 3x plus 20 equals 29. We should minus 20. I'll get 3x equals 9. Then I'll divide by 3. X equals 3. Okay? Now, if you're wanting to see, I want you to see this. Okay? I want you to see that if my point is 3 comma 5, they should both, so 3 times 3 plus 4 times 5 equals 29. 9 plus 20 equals 29. 29 equals 29. It works for that one. Now I'm going to go 3, 5 for the second equation. It was 2 times x minus 5 times y. It's supposed to equal negative 19. 6 minus 25 equals negative 19. Negative 19 equals negative 19. Okay, so I've proven that 3, 5 is truly the solution. And if you want, try this one doing substitution. Now, I went pretty slow through this, right? But substitution, even if I went slow, would probably take twice as long on this question. Would it work? Yes. Okay? Substitution and elimination both work at all times. Okay? There's many, many, many ways for me to get to work in the morning. Okay? No one would argue that. But you want to choose maybe the way that's the fastest, the least lights, the, you know, less aggravating, right? Most efficient, I think, right? That's what we always want to pursue. And that's, as you get higher in math, it's not just getting better, it's getting more efficient, okay? And the more efficient math gets, the more difficult it gets. Yes?
Okay, would there be any question that subtraction would do?
No. Addition, subtraction will always be your choice, okay? Now, what do we want to do for this one? Can we add these two together or subtract them right now and get rid of something? No. And we're always talking about a variable. I never want to get rid of the, like I don't care about these. Like if I multiplied this by 2, just to see if I can get rid of the number, I'm still got A's and B's, don't I? Right? I need to get rid of a variable. That's always your goal. Now, just for us, so for this one, we'll eliminate the B's. Okay? Do I have to? No. You could eliminate the A's, but let's just so we can get, I don't want you thinking, oh, Mr. Troll, I thought we have to do the first one. I thought we said, no, I never said that. Well, in our last 4 examples, you did the first one every time. And then I got to go, okay, you're right. I did do that every time, but you don't have to. Okay? Because sometimes the B's are really easy to get rid of. Now, I think this one's a toss-up, the A's or the B's, but let's get rid of the B's. Okay? What should I do? Yep. Okay. If I do that, I'm going to be subtracting the 2, aren't I? Okay, so that's up to you. But you have to realize if you're doing 3 and 5, you're going to be subtracting. But if I go 3 and negative 5, or negative 3 and 5, I will get to add them. Does everyone get that? Okay? Because when they're opposites, you can add them and eliminate. So this is what I often will do, and then I will write the original beside it. Okay? So I'm just going to write. Okay, so who can tell me what it would be now after I've multiplied it by 3? Who feels lucky? Yes? 72. Okay, next one. Negative 60. Okay, so whenever you have an opposite on the top and the bottom, you've achieved what you wanted to achieve. So, like I've been trying to always use the chess analogy, if you don't know where you're going, you don't know what your outcome you want to be, you're not going to plan for that, right? You shouldn't get to this point and go, oh, that's cool, look, they're going to cancel. I'd be like, well, isn't that why you picked those numbers in the first place? Okay? Now, because if I added the top and bottom, I can get rid of the B's, I will add. Okay? So, how many A's will I have? Negative 2A. Now, you can not put anything here if you like. And then what would be here? 12. Then I'm going to divide by negative 2. A equals negatory 6. Okay? Okay, pick either equation, doesn't matter. I'm going to pick 6a plus 5b equals 24, doesn't matter. So 6 times negative 6, please substitute with brackets or just write a little note to yourself that I substitute without brackets, so this will probably be wrong. So this will be negative 36 plus 5b equals 24. It's wrong. Yep. Oh yeah, if you don't have to mess with it, don't. Like if you had a 6b on the top and a 3b on the bottom, I wouldn't be multiplying the top by anything. I would just multiply the bottom by 2, or negative 2 in this case, to eliminate. Okay? So these are actually worst case scenarios. There's way, way easier ones than these. Okay? Where, hey, maybe the first question in your textbook, they're already going to eliminate. You don't have to do anything. Like maybe there's a positive 3 up top and a negative 3 on the bottom. And those are going to turn out easier. So these are the hardest they're going to get, right? Now, I'll add 36. I'll get 5b equals 60. Divide by 5. B equals 12. Okay, and then you want to check, but just for sake of time, trust me, it works. Mm-hmm. You see, yeah, this one's kind of different because it's not really coordinates x, y, is it? So I would just say, therefore, A equals negative 6, B equals 12, right? Because who's to say that's really a coordinate anymore, right? It wasn't a word question, so I don't have to answer in words. So I would just do that. Sometimes less is more. You start doing too much and then you actually get it wrong because you contradict yourself. Okay. Okay, I think here is an example of just what. Right, this is the one that you kind of were asking about. Now, remember, you got to think ahead. Who can you get rid of? X's or Y's? The X's, right? So what would we do to the top? Negative 2, right? I would go negative 2. Okay, and then we'll write it to the side here. Now you got to be very conscientious. If you multiply one of them wrong, I can 100% guarantee you, you will get the question wrong after that. It's it's going to go that way. I mean, you know how it works. You cannot just multiply one number correctly in all of them. Okay? So I get negative 6x. I got negative 8y equals negative 22. If you just messed up one negative sign there, you will get it wrong. And that's why checking is going to help you out, right? And see, the bottom I don't want to mess with. I mean, if it ain't broken, don't fix it, right? It's set up nice, right? Like, what if this was the question? They just gave me the question like that. And you know how the textbook always starts off? There's the ones that are like, you know, thanks for coming out. Do you have a pulse? They have those questions, right? And then they start getting into the harder ones. And when I keep doing these more difficult ones, students come and go, like, what do I do with this one? I said, well, just add them together. Okay. Oh. Well, that's all we have to do. Yep. Okay, so anyway, then I've got they cancel. I'm adding, remember? See, that's why I know to add, because I always add. Right? Now, if you're choosing, I'm going to subtract this time, maybe you got a coin, you're flipping it or whatever, maybe you're going to be having to be a bit more conscientious. Oh, am I adding or subtracting this time? I can't remember, right? So, redundancy breeds perfection, okay? So if you pick a way to do it every way, your way, every way, like consistently, you do become better and you do make less mistakes. So negative 8 and negative 5 is negative 13y and negative 26. Divided by negative 13. Y equals 2. Okay. Now, doesn't matter which equation you want. You can use the top one, you can use the bottom one. I think they both would be arguably the same difficulty, so you're not going to save any time. So let's use the top one. I'm going to use 3x plus 4y equals 11. I know what y is now. So 3x plus 4 times 2 equals 11. And you see, I always substitute with brackets, and that gives me my heads up. when I come back to check it over, that I know I did my substitution. So that's 3x plus 8 equals 11 minus 8. 3x equals 3 divided by 3. X equals 1. Okay, so this one, x equals 1, y equals 2. And then check, make sure. Now, when you're doing a worksheet, you're going to probably look at the answer and go, I got it right. Okay, you're not going to want to check it every time because you're going to be trying to race through this stuff, right? But you might get one, maybe two of these on an exam. So that's where you want to check it. But you also have if you got into y equals, you could plug it into your calculator and make sure you got it right. See, I'll want to see the elimination steps. I know I might just ask you, solve by elimination. And you're like, crap, I don't know how to do elimination. You'll do your graphing calculator, you get the answer. You might get 1 out of 5, right? Because I'm looking for, do you know how to use elimination? I know you know how to use your calculator. I already asked you that on a different multiple choice question. Okay, so this one is a pure word problem. So Connor downloaded 2 orders of games and songs. The first order consisted of 5 games and 4 songs for 26. The second order consisted of 3 games and 2 songs for 15. Okay, so again, we have our games, let's call it G, and our S can just be our songs. That even helps you keep things straight. Okay, so the first sentence would be 5G plus 4S equals 26. The second, no. Yeah, 3 games plus 2 songs equals $15. And again, if you asked most adults how much is a game, and they would say, well, there's a lot of possibilities. But when you give me 2 scenarios, there's only one possibility. Okay? If you just gave me 5G plus 4S equals 26, there's a million. But if you said, oh, and here's another scenario that works, there's only one after that. Okay? And if there was 3 unknowns, you'd have to give me 3 equations. I could tell you the exact answer. Okay? Now, solve it algebraically. So, get strategic. Now, I want someone to put up their hand and tell me what they would do to solve this one. Okay? Some people are like not making eye contact with me right now. What would you do? Right, okay. So if you multiplied this by -2, you would be able to eliminate by adding. Okay? So I'm just going to write this to the side. This is 5G plus 4S equals 26, meaning I have not done anything to that one. This one will be -6G minus 4S equals -30. Okay, now I will add them together. 5G and -6G is -1G. I can cancel that, equals -4. Divide by -1, G equals 4. Okay. Now, this one, why don't we substitute in the second equation? Why? Because we haven't done it before, so let's do it now. So I'm going to sub into 3G plus 2S equals 15. So 3 times 4 plus 2S equals 15. So then I'll have 12 plus 2S equals 15. We'll subtract 12 to both sides. 2s equals 3. Divide by 2. S equals 3 over 2. And in this case, 1.5. Again, not a very realistic answer, but we're doing this one together. So, or no, sorry, no, this is price. Yeah, so that's reasonable. I thought it was yeah, it was number of, like, so the price of a game and a price of a song. So that's a reasonable answer. I had it mixed up in my head that I was looking for how many songs, but we knew how many songs. It was the price. Okay? So now you should always verify. So we can do, does 3 times 4 plus 2 times 1.5 equal 15? 12 plus 3 equals 15. 15 equals 15. Okay, and then you can check the other one too. So therefore, or 3 dots, games cost $4 and songs cost $1.50. Well, this is like iPad stuff, man. That makes sense. $3.99. Okay, let's do another one. Holy, we got like 2 more here. Okay, I don't know how many more we want to do here. No, let's do this one, and then that's it. Okay, because this is I always want to get you used to this one. So we've got during lunch, the cafeteria sold 160 muffins and yogurts. The price of each muffin was $1.50. Each container of yogurt is $2. The cafeteria $273.50. Set up a linear system in order to determine the number of muffins. Now you can just imagine how easy this is to mark as a written response question on an exam. Like, number 1, list your variables. Number 2, write a system to start. Okay? Now, let's go muffins, right? Hopefully you're not struggling with this part. And Y is yogurt. Now, actually, let's be specific. M is number of muffins, right? Not price. So maybe I would have been better off on that last question to have said the price of a game, or the cost of a game, the cost of a song. And then this is number of yogurts. Now, obviously, the success comes from your system. If your system is incorrect, unless you're having a really lucky day, you are not going to get the correct answer. So who can give me my equations for this? Sure. M plus Y equals 160. Okay, so there's always your number statement, and then there's always your... Yeah.
1.50 M plus 2Y equals 273.50.
Okay, and if you want, you can put this there for yourself to remember that's money. So why did I want to do this one? Because I want to keep reiterating that whenever you get these, they're going to give you a number statement, and they'll give you the total amount of money collected statement. You got to get used to doing this. Okay, now maybe on this one, I would go substitution, right? This one's nice to go substitution with, but we're learning elimination. We're going to do elimination, okay? But I would go substitution on this one. But actually, to tell you the truth, I always like elimination, so I will always go to that. But because I'm used to obviously doing grade 11, grade 12, and Math 31 stuff, so I get used to not using substitution very much, okay? Anyway, what's a good way to go with this one? Yeah, what would you do, Prashant? You could. Yeah, negative 1.5. Would that work? Yes. Okay. I think you should be nice to yourself, though. I like negative 2, right? But you know what? Would you get it right? Would it be that much harder? No. I mean, it wouldn't be harder, no. You'd get it right, right? Yep. You're going to pull off a decimal when you add those two together, though. Right? Because if you do negative 1.5, what's going to happen when I add those two together? I'll get a 0.5 anyway. Okay? Still going to work. Okay, so I'm going to multiply the top statement by 2. Negative 2, sorry. So, and I want to write it beside it. Negative 2m minus 2y equals negative 160. And then this one is going to stay 1.5m plus 2y equals 273.50. If I add the two together, oh, sorry. I got the negative right. That's what I was looking at. I'm like, it's negative. I don't know what you guys are. Fine. You guys are pretty high maintenance. Okay, so let's add them. What happens when I add the top to the bottom? You can cross that out, but what's this going to be? Negative 0.5m equals, I'll just do this one, negative 46.50. Then you'll divide by negative 0.5. You definitely do not want to come out with a negative number here. That doesn't make sense, right? So this is nice. My negatives will turn into a positive. So m equals 93. And because it stands for number, I would be not expecting a decimal. If it was money, decimals are fine. But this would be discrete data, right? We're not going to be buying half of stuff. So now, if that's m, I'm going to use the m plus y equals 160. 93 plus y equals 160. Subtract 93. Subtract 93. Y equals 160 minus 93. 67. Okay. To verify, it doesn't matter which one you pick. Obviously, I know m plus y equals 1/6. That makes sense. Let me just do the other one. 1.5 times 93 plus 2 times 67 is supposed to equal 273.50. So I'm going to do the left side here. That's 139.50 plus 134. Okay, I add those together. I do get 273.50 equals 273.50. Check it. The sentence, therefore, there were 93 muffins and 67 yogurts sold. Okay, so I would like to give you lots of time to work on these. So this one, this is an easy one as well. That's just very similar to the quiz you wrote today. But why don't we get right to, so you haven't been overloaded with problems there, but again, some are going to be very, very easy when you begin. So don't get confused. Sometimes you can just add them together right away. You can even subtract them right away, but if they're going to subtract, you can take 1, multiply it by negative 1, and then add if you want to be consistent in your practice. Question?
How would you go about doing that? Because you have a variable at the side. Because like you have where it's like, you have your
Yeah, okay, it's not a bad idea. Let's just talk about the setup. Okay, this will take 2 minutes. The perimeter of a rectangle is 17 meters. Triple the length is 246 meters longer than 5 times the width. Determine the dimensions. Okay, so that wording's weird. I think the first one's not too bad. Okay, well, my variable is L is going to equal length. W equals width. Okay, so this statement here, I think we should be okay with. Okay, and another thing too, I'm definitely a visual learner, so pictures help, and that picture might help me with my second equation. The first equation, 2L plus 2W equals 17. Okay, I think that one's the no-brainer. Now we've got to figure out the second one. Triple the length is 2.46 meters longer than 5 times the width. Okay, so if we even came up here, we've got triple the length is 3L. Is stands for equals. So triple the length. What if it just said the length is 2.4 meters longer than the width? Well, that's why we're going through it, okay? Those comments don't help. So the length is 2.46 longer than 5 times the width. So if I got rid of the triple and the 5 times, if I said the length is 2.46 longer than the width, yeah, that's what I would do, but I want to make sure everyone can see that. So triple the length. So what's bigger, the length or the width? Okay, the length is bigger. So we know that length, this isn't true, is it? Okay, to make them equal, the length, yeah, that would make those two equal each other. Do you see that? Okay, so that's how I always think about it. But then we've got to put the 3L and the 5W in there, right? Okay, so this is why Zach was like, whoa, how are we going to do this one? Okay, so I got 3L equals 2.46 plus 5W. Now, what was the very first thing that I said when we did these? We need to line up the equal signs, we need to line up the L's, and we need to line up the W's. So, what needs to happen? Yeah, be specific though. So I need to bring 5W on this side of the equal sign. Do you see that? Okay, which would make it 3L minus 5W equals 2.46. Okay, so just to reiterate, this is what it would now look like. 2L plus 2W equals 17, and 3L minus 5W equals 2.46. Okay, now the rest, can you do that one on the rest if you had to? Multiply the top by 3, maybe the bottom by -2, add them. Okay, there we go.